Hello all. In this video we'll learn about some of the types of functional dependencies and the normal forms. Let us understand what is functional dependency. A functional dependency is denoted by x tends to y, means that the value of y are determined by the value of x. For example, we can determine employee name using SSN. So SSN determines employee name. At the same time, if I consider a student relation, student name can be determined by USN number. So USN determines student name. Yes. If I consider project number, the project number will determine project name and the project location. Yes. To determine the hours is nothing but the number of hours employee working on a particular project. If I want to determine the number of hours where an employee working on a particular project, so I require SSN and the project number also. Okay, so SSN and project number determines hours. Okay, so this is about the functional dependencies. Yes, let us understand about the types of functional dependency. Now first we'll understand there are 4 types of functional dependency: fully functional dependency, partial functional dependency, and transitive dependency, and trivial functional dependency. Yes, let us understand about fully functional dependency. A functional dependency x tends to y is fully functional dependency if removal of any attribute a from x. If I remove any attribute a from x, means that the dependency does not hold anymore. For example, let us consider this dependency. SSN, project number determines hours. So here, even if I remove any of the attribute, I cannot determine hours. So to determine hours, I need both these attribute, SSN and project number. So then it is called as a fully functional dependency. So if removal of any attribute a from x, if I remove any attribute that is any attribute from this x, means that the dependency does not hold anymore. So in other way, to determine hours, I need both these attributes to determine hours. So it is called as fully functional dependency. Yes. Let us understand about partial functional dependency. A functional dependency x tends to y is partial functional dependency if removal of any attribute a from x. If I consider this as x, if I just remove removal of any attribute a from x and the dependency still holds. Let me consider this example. Here we have in the left hand side we have SSN, project number determines employee name. Yeah, the thing is to determine employee name, only SSN is enough. Just by using the attribute SSN, I can just determine employee name. So I did not make use of this project number. This is not required to determine employee name. So as per the definition, if removal of any attribute from attribute a from x and the dependency still holds. So yes, as you can see here, even if I remove this project number, the dependency still holds. So this is called as a partial functional dependency. Okay, so this is called as partial functional dependency, because SSN employee name can be determined by using SSN. So understood the difference between fully functional dependency and partial functional dependency. To determine in fully functional dependency, we will be using both the attributes in the left hand side, but in partial functional dependency, using any one attribute we can determine employee name. So that is called as partially dependent. Okay, yeah, these two dependencies are very important to understand the normal forms. Yes. Transitive dependencies. Okay, A functional dependency x tends to y in a relation schema R is a transitive dependency if there exists a set of attributes z in R such that x determines z and z determines y. So according to the transitive dependence, x determines y. Okay, so this is called as transitive functional dependency. Let me explain this transitive dependency using a simple example. Yes, as you can see here the dependency ssn determines the department manager ssn is transitive because, see here, yes, ssn determines department number and department number determines manager ssn. So according to the transitive dependent, ssn can determine manager ssn. Okay, so this is called as transitive functional dependency. Okay, as you can see, this is called as transitive functional dependency. Okay. What is trivial functional dependency? If a functional dependency extends to y holds where y is a subset of x, then it is called as a trivial functional dependency. For any functional dependency x tends to y, if y is a subset of x, then it is called as a trivial functional dependency. Well, if it in opposite case, if a functional dependency x tends to y holds where y is not a subset of x, then it is called as a non-trivial functional dependency. Yes, yes, we learned about these four types of functional dependency. It is very important to understand the normalization, normal forms. The first one is the fully functional dependency. Second is partial functional dependency. Then transitive dependency, and the last one is trivial functional dependency. Yes, let us understand about the basics of normal forms. In 1972, Code proposed three normal forms, so which he called first normal form, second normal form, and third normal form, and Boyce Code normal form as well. So all these normal forms are based on functional dependencies among the attributes of relation. So yes, later a fourth normal form and fifth normal form were proposed based on the concepts of multi-value dependency and joint dependency. Okay, yes, totally there are first, second, third Boyce Code normal form, fourth normal form, and fifth normal form. So totally six normal forms including BCNF. Yes, normalization of data. Now the question is, why we need to perform normalization? What is this process all about? Normalization of data can be considered a process of analyzing the given relation schemas based on their function dependency and primary keys to achieve the desirable properties. So what is a property? What is the main use of normalization? The first one is minimizing redundancy. It's very important. Why normalization is used? It is used to minimize the redundancy. Second, minimizing the insertion, deletion, and update anomalies. Okay. Uh, it can be considered as filtering or purification process to make the design have a successfully better quality. Just if I want to if I improve my quality of my relation schema, I just perform normalization to that particular relation schema. Okay, it's a responsibility of the database administrator that the relation schema should be normalized. Okay, the normal form of relation refers to the highest normal form condition that it meets and hence indicates the degree to which it has been normalized. Usually, a grading will be given to any particular hotel, whether it's a 3-star or 5-star or whatever, 7-star. So same way for the relation schema, we just based on the quality of the relation schema, we give the gradings in terms of normal forms, whether it is in a first normal form, second, third, or yeah, fifth normal form. So this is about the basics of the normal forms and the definition. As I said, it is used to minimize redundancy and to minimize the insertion, deletion, and updation anomalies. Now let us look into understand about the first normal form. Yeah, before learning the first normal form, yes, we'll learn some of the definitions of keys and attributes participating in the keys. Okay, what do you mean by key? A key is a super key with the additional property that removal of any attribute from K will cause K not to be a super key anymore. Okay, now the question is, what is the difference between a super key and a key? The difference between a key and a super key is that a key has to be minimal. Okay, so super key can have some of the redundant attributes. Yes, uh, consider a super key here. SSN comma employee name is a super key where SSN is a key. Okay, so SSN is the key for an employee, whereas SSN or SSN comma employee name or SSN comma employee name comma birth date, so all these set of attributes are called as super keys. Usually super key may come in a single or in form of a set of attributes, whereas a key is a minimal attributes. Okay, yes. Yes, let us understand about some of the candidate keys and prime attributes. Well, if a relation schema has more than one key, so each key is called a candidate key. Okay, so one of the candidate keys is arbitrarily designated to be the primary key. For example, if I consider a student table, we have USN number, Aadhaar number, or PAN number, or voter ID number. So all these uh, are attributes are called as candidate key. One of the candidate key is arbitrarily designated to be primary key. For example, in a student table, we consider USN number as a primary key. The rest all Aadhaar number, PAN number, rest all are candidate keys. So out of n number of candidate keys, one attributes we just select it as a primary key. Okay, yes. Now, let us understand about the prime attributes. An attribute of a relation schema R is called a prime attribute of R if it is a member of some candidate key of R. Oh yeah, if it is a member of a candidate key, then it is called as a prime attribute. If I consider an example of a student table, here your USN number of a student, Aadhaar number, PAN number, or voter ID number, all these are called as a candidate key. Okay, and also I can consider it as a prime attribute. An attribute is called non-prime if it is not a prime attribute, that is, it is not a member of any candidate key. For example, student location or address, all these are not a not a candidate key. So it is a non-prime attribute. SSN and project number are prime attributes of works on, whereas other attributes like works on are other attributes of works on are non-prime attribute. Okay, like the project name or project name, it's not a it yeah, or employee name is not a prime attribute, because there might be a chance that two employees can have a same name. Yes, now let us understand about first normal form. First normal form states that domain of any attribute must include only atomic values. That is, it should be simple and indivisible. So, and the value of any attribute in a tuple must be a single value from the domain of that attribute. Yes, as you can see here, the domain of the attribute should be always single. Okay, it should be indivisible. Okay, and it cannot have multiple values. So in case if at all if there is any multiple values, we need to convert into a single values. Okay, so we need to convert into a first normal form. Okay, now the question is how to convert this table into a first normal form. So this is not in first normal form because the domain of an attribute should be always single. So here it has multiple attribute, so we need to convert this into a first normal form. Yes, there are three main techniques to achieve the first normal form for this kind of relation. That is, just as you can see here, the department location consists of three locations in a single domain. So we need to remove the attribute delocation that violates first normal form and place it in a separate relation called as department locations along with the primary key department. So this is one method to convert this table into a first normal form. We need to decompose it, remove this department location, create a separate location with its primary key, which is the primary key of department D number. Using the primary key, we make a separate table. Okay, so yes, as you can see here, separate locations. Here you can see all the locations are single. We just split the single row into a multiple rows here. Yes, as you can see here, Bel Air, Sugarland and Houston all belongs to department number 5. This is how we just split the row into 3 rows. Okay, this is one way of technique to achieve first normal form. Let us look into the other two techniques. Yes, as you can see here, expand the key so that there will be separate tuple in the original department relation for each location of a department. As you can see here, in the department table itself, just split this single row into 3 rows, as you can see here. But the solution has the disadvantages of introducing redundancy in the relation. Yes, as you can see here, here are the redundancy. This is a redundancy because here is a duplicate values. Well, this is only the 5 rows. Well, if the data is consist of 10 lakhs or 500 lakhs of data, in that case this will create a huge problem. So this is a redundancy. Yeah, well, look into the third technique. So if maximum number of values is known for the attribute, for example, if it is known that at most 3 location can exist for a department, so replace the department location attribute by 3 atomic attributes. So that is, we need to, according to the third technique, we need to split the column, that is as department location 1, location 2 and location 3. So well, if some department there are only 1 location, rest 2 location we need to mention it as null value. So this solution has the disadvantages of introducing null values if most departments have fewer than 3 locations, which means less than 3 locations we have to place null values. Again, this technique is not recommended because it can have null values. Even second technique was not recommended because it consists of a redundant data. Second normal form. A relation schema R is in second normal form if every non-prime attribute A in R is fully functionally dependent on the primary key of R. Yes. So second normal form is based on the concept of fully functional dependency. So there should not be any partial functional dependency according to the second normal form. Let's understand what is fully functional dependency. Whenever the x tends to y is fully functional dependency, if removal of any attribute A from X means that the dependency does not hold anymore. Yes, now if I consider this functional dependency, SSN comma project number determines hours. So this hours is nothing but the number of hours employee works on a particular project. Yes, to determine hours we need both SSN and project number. So this is an example of fully functional dependency. Yes, what is partial functional dependency? Whenever x tends to y is a partial functional dependency if removal of any attribute A from X and the dependency still holds. The dependency SSN comma project number determines employee name is partial because employee name can be determined only by SSN. Okay, so hence it is called as a partial functional dependency. Yes, as you can see in the slide, we have a table with the name employee project. So here it's a combination of 2 tables. Okay, and yes, as you can see, the function dependency 1, SSN and project number determine hours. Yes, it is a fully functional dependency. And let us look into the functional dependency 2 here. Here SSN determines employee name. Yes, this is not fully functional dependency. This is a partial functional dependency because here we have a 2 primary keys, that is SSN and project number. As you can see, there are 2 primary keys. But to determine employee name, it could be done only by SSN. We did not use project number. So this is a functional dependency 2 is a partial functional dependency. Okay. Talking about third functional dependency, yes. Even third functional dependency is a partial functional dependency, that is to determine project name and project location. I will be using only project number. I will not be using SSN. So FD2 and FD3 violates second normal form. So well, in that case, now the question is how to convert this into a second normal form. So we need to decompose the original table, or break this original table into pieces. Now how we need to decompose? Yes, we need to remove this. You know what is that? Second functional dependency, SSN and employee name. You just decompose it and make it separate table. Yes, as you can see here, we have made a separate table for SSN and employee name. Yes, coming to functional dependency 3 here, as you can see, project number, project name and project location, just remove it from the table and make it separate. As you can see, FD3, project number, project name and project locations, we have just broken the entire table into 3 tables, and the first table is as it is. As you can see, SSN, project number and hours based on the functional dependency 1. You keep it as it is. Rest everything you just break into pieces and make it separate table. As you can see, if function dependency 2, this is why we broke down this based on the function dependency. Okay, so this is how now I can say that all these 3 tables is in second normal form. Okay, yes, as you can see, hours is fully function dependent, and yeah, employee name is fully function dependent on this SSN, and project name and project location is fully functionally dependent on the project number. So this is how we just converted a table into a second normal form just by decomposing it based on the functional dependency. Yes. Let us look into the second example on second normal form. Let us consider a relation schema lots. Okay, there are 2 candidate keys in that is property ID and county name comma lot number. Okay, it's a second candidate key is a combination of county name and lot number. Yes, lot numbers are unique only within each county. So, but property ID numbers are unique across the countries for the entire state. So that's in a relation schema lots. We have a 2 candidate key, that is property ID and the combination of county name comma lot number. Okay. Yes, let us look into the example here. Yes, we have an example here. We have a property ID. We have a property ID, county name and lot number here, both is a candidate key, and here the property ID is also a yes, candidate key, or I can say it as a primary key. Okay, so then area, price and tax rate. So now as you can see in the functional dependency 1, using the property ID, I can determine county name and lot number, area, price and tax rate. Yes, as you can see, the non-prime attributes are fully functional dependent on the property ID. Let us look into the second functional dependency. County name and lot number determines property ID, area, price and tax rate. Yes, the non-prime attributes like area, price and tax rate is fully functional dependent on the prime attribute. No wrong in it. Let us look into the function dependency 3. We need to check whether they should not be, as per the second normal form, informally, they should not be any partial functional dependency. Let us look into the functional dependency 3. Tax rate, as you can see, tax rate is determined by county name. here just by using a county name I can determine county name can determine tax rate. Yes, this is FD3 is a violation of second normal form. So as per the definition of the second normal form, there should not be any partial functional dependency, but the functional dependency 3 is partial functional dependency because we can determine tax rate just by using county name. Because candidate key here, it is a combination of county name and lot number. Just by using county name one can determine tax rate. So in that case we need to decompose into a second normal form. Well, in FD4, yes, area determines price. Here both are non-prime attribute. Yes, there is no partial function dependency here. Yes, coming to the FD3 is violating violation of second normal form. So in that case we need to break down county name and tax rate should be made a separate table. As you can see here, we have just split the table and we have made a separate table for the county name and the tax rate, that is for the functional dependency 3. The rest is as it is. So this is how we just converted a table into a second normal form. Yes, let us understand about the third normal form. Here's a definition. A relation schema R is in third normal form if it satisfies second normal form and no non-prime attribute of R is transitively dependent on the primary key. Yes, here third normal form is based on the concept of transitive dependency. A functional dependency x tends to y in the relation schema R is a transitive dependency if there exists a set of attributes z in R such that x tends to z and z tends to y hold. Yes, so that is called as transitive dependency. As you can see here, yes, x determines z and z determines y. So I can say that x determines y. So this is what it's a transitive, as per the transitive rule, x determines y. Yes, so as you can see here, for taking an example of transitive dependency, if SSN determines department number and department number in turn determines department manager. So according to the transitive rule I can say SSN of an employee determines the department manager. So this is the transitive dependency. There should not be any transitive dependency according to third normal form. Yes, let us understand this third normal form with an example. Now we need to check whether there is any transitive dependency or not. Yes, as you can see here, SSN determines employee name. Fine. SSN determines birth date, address and department number. As you can see here, SSN determines department number, but you can see here in turn department number determines department name and department manager SSN. As you can see here, this is a functional dependency. Department number determines department name and manager SSN. So there is a transitive dependency here, that is SSN can determine department name and SSN also can determine department manager SSN according to transitive dependency. So we need to split this. So and make a separate, decompose the table. Okay, split it and just decompose the table. Yes. So now this is how we just converted the table into a second normal form, where we found there was a transitive dependency. So between SSN, department number, and department number in turn determines department name and manager SSN. So we just split that department name and manager SSN with department number and made a separate table. So now this is how we just convert the relation into a third normal form. I can say that the corresponding two relations are in a third normal form. Yes. Yes, now let us understand about one more example for the third normal form. as you can see, in the functional dependency 1, check whether as per the third normal form there should not be any transitive dependency. Now yes, let us understand about the functional dependency 1, fd1. Property id determines county name, lot number, area and price. Yes, and county name and lot number determines property id, area and price. Now just look at fd4. Area in turn determines price. Area determines price. County name and lot number determines area, and area in turn determines price. So this is transitive. There is a transitive dependency here. So we need to decompose area and price, make it separate, and this is how we just decompose it. Price, you just split it from the original table, and within that price, area is also split it, is added to that. Okay, so this is how we just decomposed a table into two tables, and now I can say that these both relation are in third normal form. Yes, that's it about third normal form. We just learned about the first normal form. The first normal form is based on the domain value should be single and simple and indivisible, and second normal form, there should not be any partial functional dependency, and in third normal form there should not be any transitive dependency. So in the next video we'll learn about voice code normal form, and the fourth normal form and fifth normal form. So the fourth normal form and fifth normal form is based on multi-value dependency and joint dependency. Yes, thank you so much for watching this video.